KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class, we start with the 22nd problem. So, in our last class, we finished the 21st problem. So, in this class, we start with 22nd problem, right? First see the problem, then we will go for solution. See here. At what angle should a ray of light be incident on the face of a prism of refracting angle 60 degrees so that it just suffers total internal reflection at the other face, okay, right. The refractive index of the prism is 1.524, right. So, here if you observe carefully, you know very well what is prism, right. So, prism is a piece of glass material, but not only one type, we have different types of glass. For example, flint glass, for example, crown glass, for example, ground glass. So, there are various types of glass material, right. So, what type of material you want, with that you can make a prism. That is what prism is, a rectangular shape, no. So, the shape is important here. The shape is important here, right. Okay, that will be, see, it is what, sorry for saying, I think I used the prism is rectangular, no, sorry, it is a triangular prism. So, whatever the prism we consider, it is a triangular prism, right. There are rectangulars also, that will be different. Here we are using only triangular prism, okay, right. And what is the prism means, you know that triangle in shape, right, and these two are said to be faces of prism. This is one face of the prism, the other face of prism, and these three are the angles ABC, right. So, generally you know very well, suppose if it is equilateral triangle, right, need not to be, but I am saying if it is equilateral triangle, you know all the angles are same, that is what 60, 60, 60. Suppose if it is right angle triangle, right, that will be different, but here this is what equilateral prism, right, here this is the triangular prism, and what about these angles, that we will find out. In this problem it is okay, this is what 60 degrees, angle of prism is 60 degrees, but we are not sure about the angle 60 degrees because in some problems, in some situations, they will ask to find, and they will give you, right, whether they will ask to find, otherwise they will give us to calculate, right. That is why do not fix that it has 60 degrees. Suppose if it is equilateral prism means you can take it as 60 degrees, no problem, okay, right. And one more thing is, it is what in this prism, it is what incident ray, no, it is what first refracted ray, it is what here the ray is not going to refract, the ray is going to reflect, that is what total internal reflection, okay, right. It is ABC name of the points, that is what vertices of, that is what like a triangle, and here this is what PQ is the incident ray, you know this is the Q, right, it is PQ, and QR is the first refracted ray, right. Next this is what R, right, it is what internal reflected ray, right. So, you can say that RC, right, RC is the total internally reflected, right, it is what R1 and it is R2, okay. So, it is the angle of refraction at first refraction, and it is what angle of incidence will become like that, right. So it is what for second refraction, before the second refraction, and this is the normal and this is also normal, right? So this is all about the prism, okay? So through that prism we are going to observe the refraction and total internal reflection also. What are the uses of prisms means, you know, the prisms are using in binoculars, right? Not only one application, here I am saying one application, right? So there are a lot of applications. One of the important and very near application is, that is what in case of binoculars we are using prisms, right? You can use a lens also in binoculars, but lens are very, thickness is very less. So because of thin lenses, if you use thin lenses in binoculars, the handling, and if you drop the binocular from certain height, it will be broken, right? So the lens will be broken. That's why it is better to use prisms, because if you use the prisms, right, it won't it won't break, right? So lifespan and economically it is what saving, right? And there is no breakage, means while carrying from one place to another place also we will feel comfort, okay? So these are the advantages of prisms over lenses, right? That is the see. So at what angle should a ray of light be incident on the surface of a prism of refracting angle 60 degrees, so that it just suffers total internal reflection at the other face? This is the other face, right? Full stop. The refractive index of the prism is 1.524, right? Here, at what angle should a ray of light be incident means he is asking to find angle of incidence, right? You know that angle of incidence is the angle between incident ray and normal, right? Okay. So that we have to find here. So further what they have given, it is what refracting angle 60 degrees, that is what A is equal to 60 degrees given, right? And one more thing also given, that is refractive index of material of the prism, that is what 1.524, okay, right? See this, the refracted ray QR will just suffer total internal reflection if it is incident at the critical angle, right? So what is critical angle, right? Critical angle is the angle of incidence for which the angle of refraction is 90 degrees, right? Critical angle is the angle of incidence for which angle of refraction is 90 degrees, right? That is what. So what I am saying is here, right, critical angle is the angle of incidence for which angle of refraction is 90 degrees. So see here, right? So this is what R2. When the ray is going to total internally reflected, then we can write R2 is equal to IC, no? R2 is equal to IC, right? Okay. Then you know the relation between critical angle and refractive index, that is what sin IC is equal to 1 by mu. Sin IC is equal to 1 by mu. Sometimes we are writing sin C is equal to 1 by mu, right? Whatever it may be, but here IC is the critical angle, okay. Sin IC is equal to 1 by mu, no? Right. 1 by, what is this mu? 1.524, right? So 1 by 1.524 is equal to 0.06542. 0.06542, right? So from this, IC is equal to sine inverse of 0.06542, right? So it's a mathematical thing. So when it is sine inverse of 0.06542, which is approximately equal to 41 degrees, right? So sine inverse of sine 41 degrees. So sine inverse into sine almost will get cancelled. Then the answer will be 41 degrees. So here this angle became as 41 degrees right now. One more condition in case of this prism and the ray diagram, R1 plus R2 is equal to A. R1 plus R2 is equal to A. We can write that. It is also, this one we are also getting when we derived an expression for refractive index of a prism, that is what mu is equal to sin A plus D by 2 by sin A by 2, right? So while deriving that formula, in case of prism, we got this condition, that is what R1 plus R2 is equal to A, right? Once you go through the derivation, then you can realize why we are writing here R1 plus R2 is equal to A. But it is not a secret, but it's just geometrical mathematics, right? So it is what quadrilateral, and it is one triangle and it is another triangle, right? And the sum of three angles in a triangle is equal to 180, right? So here also it is also one of the triangle. It is what R1 plus R2 plus this angle is equal to 180, and here also this is what, okay? And at the same time the opposite angles. So these are, so geometrical mathematics will give us R1 plus R2 is equal to A. Then from this you can write, from this you can write mathematically R1 is equal to A minus R2. So then what about this R2? R2 is equal to IC, no? When this ray is going to total internally reflected, then R2 is equal to IC, no? When R2 is equal to IC, so what about this? You can write R2, you can write IC. So that is equal to, see, A is equal to 60 degrees given in the question, and IC is equal to 41 degrees we calculated. So that it will be 19 degrees. R1 is equal to 19 degrees, right? So this is 90 degrees, 19 degrees, right? From Snell's law, mu is equal to sin I by sin R. It is the second law of refraction, right? Here sin I1 is equal to mu into sin R1. Okay, so here it is what, if you substitute these things, so what we have to substitute? Generally mu is 1.524 and sin, what is R1? 19 degrees. So 1.524 into sin 19 degrees will give you 0.4962. So after substituting the numerical values in place of mu and R1, and after completion of calculation, right, we will get it as sin I1 is equal to 0.4962. Then I1 is equal to sin inverse of 0.4962. It will be approximately equal to 30 degrees. You know very well that is what sin 30 is equal to 1 by 2, that is equal to 0.5, right? So rounding off method, right? So this will be 6 and this will become 5, right? So finally it is sin inverse of 0.5. So I1 is approximately equal to 30 degrees. So whatever he is asking to found, that is what, at what angle should a ray of light be incident on the surface of a prism of refracting angle 60 degrees, so that it just suffers total internal reflection at the other face. Means that angle is 30 degrees. Okay. Next problem. It is 23. See here. First I will read the problem, then we will go for solution. See here. You are given prisms made of crown glass and flint glass with a variety of angles, right? You are given prisms made of crown glass and flint glass with a variety of angles. Full stop. Suggest a combination of prisms. Suggest a combination of prisms which will A. Deviate a pencil of white light without much dispersion. B. Disperse a pencil of white light without much deviation, right? So we have to give the combination of prisms, right? In one case deviation without much dispersion. In another case, dispersion without much deviation, right? So that we have to give, that type of combination we have to give, right? See this. First, so two identical prisms, that is what, made of the same material, placed with their base on opposite sides are the incident white light and faces touching parallel will neither deviate nor disperse, but will merely produce a parallel displacement of the beam, right? You just imagine the situation, what he is giving. So according to that situation, whatever the output he is saying, that is correct. Okay. So here two identical prisms made of the same material, placed with their base on opposite sides. Placed with their base on the opposite sides, or the incident white light, that is what in the bracket they have given, right? And faces touching or parallel, touching or parallel, will neither deviate nor disperse. When it is possible, when you take the two prisms of same material, this is the condition. What is the condition? What is the output? Will neither deviate nor disperse, will purely produce a parallel displacement of the beam. Okay, right. Anyhow, at this moment now, angular dispersion produced by crown glass prism is, this formula already you know, that is what? Delta B minus delta R. Delta B minus delta R is equal to mu B minus mu R into A. You know one formula, that is what? Delta is equal to mu minus 1 into A. Right? Here we are writing for crown glass prism, delta B minus delta R is equal to mu B minus mu R into A. Next, mean deviation produced by crown glass prism. See here, mean deviation produced by crown glass prism is delta Y is equal to mu Y minus 1 into A. I already told you just now the formula, that is what? Delta is equal to mu minus 1 into A. So here we are writing delta Y is equal to mu Y minus 1 into A. It is also for crown glass, but it is angular dispersion. It is what? Mean deviation. Next, angular dispersion produced by Flint glass prism. Flint glass prism, right? See, we are writing in this manner. That is delta B dash minus delta R dash is equal to mu Y dash minus 1 into A dash. Next, here you can write same how we have written for crown glass. Similarly, we are writing for Flint glass. That is what? Delta Y dash is equal to mu Y dash minus 1 into A. So this is the information. Just before going to answer for A and B, see A, what we have to answer? D, a pencil of white light without much dispersion, right? First, now we are going to answer to this, right? So before that we discussed what is possible and what about the angular dispersion and what about the mean deviation. Next, see this. A, to deviate a beam without dispersion, the net angular dispersion produced by the combination must be 0. This is the condition we must understood. Right? So that condition we are going to satisfy. So it is just theoretical information. It is what? Mathematical with notations. So what is the refractive index? What is the angle of prism? Right? That is what for different colors. That is the thing. I will repeat once again the condition. You always keep in mind, this condition also directly will come like one question in NEET exam. That is what one question means, it will give you 4 marks. Even in mains also, right? So this is very important condition for us in case of prisms. So what is that? To deviate a beam without dispersion, the net angular dispersion produced by the combination must be 0. So just the same condition we are writing in mathematical form. That is mu B minus mu R into A plus mu B dash minus mu R dash into A dash is equal to 0. So from this we are writing this one just mathematically. That is what? A dash is equal to minus mu B minus mu R divided by mu B dash minus mu R dash into A. Right? That is okay. But here negative sign is there, no? So what this negative sign is showing? Negative sign shows, okay? Negative sign shows that the two prisms must be placed with their bases on opposite sides. See here, negative sign shows that the two prisms must be placed with their bases on opposite sides. As mu b dash minus mu r dash for flint glass is more than mu b minus mu r for crown glass, therefore a flint glass prism of small refracting angle should be combined with a crown glass prism. See here, should be combined with a crown glass prism, so that the dispersion due to that, right? So that the dispersion due to the due to the first is nullified by the second as shown in the figure A. So this is what. See, what is this here? 72 degrees. What is here? 43 degrees. What is this? What is this? Okay. What is this, ma? Crown glass. What is this? Flint glass, right? Flint glass, right? So finally what we are getting? What we are getting? Deviation without much dispersion, right? Deviation without much. See here, this is the what incident right now. So it is what? So deviated, but there is no dispersion. Dispersion means what? The phenomena of splitting. The phenomena of splitting a white light into its component colors. Here it's not happening now. This will be different. I am not talking about figure B now. I am talking about only figure A, right? So according to this figure, there is no dispersion, only deviation is present. Okay, right. Now we are going for B. Now we are going to see B. So what is B here? Disperse, that is what in the bracket, and displace, right? So disperse a pencil of white light without much deviation. Without much deviation. So that we have to give. So the combination of prisms we have to give. For this condition, what he is asking, that is what? Dispersion without deviation, without much deviation. Okay, right. See this. To produce dispersion without deviation, the net mean deviation should be 0. Then the net mean deviation should be 0. So in this previous condition is what, ma? To deviate a beam without dispersion, the net angular dispersion produced by the combination must be 0. But to produce dispersion without deviation, the net mean deviation should be 0. That is what? Mu y minus 1 into A plus mu y dash minus 1 into A dash is equal to 0. So by solving this, just by solving this, just we are writing A dash in terms of A. Mathematically, will give us this expression, that is what? A dash is equal to mu y minus 1 divided by mu y dash minus 1 into A. Okay, right. Here if you observe carefully, there is no space to write, that's why I am saying you just concentrate. We take a crown glass prism of certain angle, right, and go on increasing the angle of flint glass prism till the deviations due to the two prisms are equal and opposite. See, he is explaining the process, how to achieve the requirement, how to achieve the thing what he is asking in the problem. So what he is saying, we take a crown glass prism of certain angle and go on increasing the angle of flint glass prism till the deviations due to the two prisms are equal and opposite. Okay, full stop, right? However, the flint glass prism angle will still be smaller than that of crown glass, because flint glass has high refractive index than that of crown glass. So whatever he is giving the reason, that's already we know, that is what the relation between refractive index and angle of prism, that is what. Okay, so here he is saying that the flint glass prism angle will still be smaller than that of crown glass, because flint glass has higher refractive index than that of crown glass. So you can see the situation in figure B. Okay, so this is what we have to do to achieve the required condition or the required situation what he is asking, that is dispersion without much deviation. Okay, at last I want to say some information, that is what due to the adjustments involved for many colors, due to the adjustments involved in for many colors, the above combinations are not very accurate arrangements for the purpose required. So, either in case of A or in case of B, what I told, what we discussed to do to achieve deviation without much dispersion or dispersion without much deviation are not accurate, okay, because of adjustments involved for many colors, right? So white light means not only 3 colors, no, not only violet, not only yellow, not only red. There are 7 colors which are Vibjor, right? So from violet to red. So because of many colors, these are not accurate to get these conditions what he is asking. Okay, right. So in this class we completed to discuss 2 problems, 22nd and 23rd. In our coming class we will go for next problems. Thank you.